Micrium is yet another RTOS provider. So like Kurt mentioned at the beginning of the presentation, you certainly do not lack for choice under MPLAB Harmony. Like many of the guys you've heard from already, Micrium really started around a kernel. Our software today is based on the original MicroCOS. It was written by Jean Labrosse, our founder. That software was first released in 1992, so we have a very established code base. We've evolved from there to MicroCOS 2 and MicroCOS 3, which are our two primary kernels today. But like many of the software providers you've heard from today, we have a complete line of RTOS components built around our kernel now. So we've expanded from just the kernel. We offer a TCP/IP stack, USB host and device stacks, file system, GUI, really a complete software platform. Our modules are always provided in source code. Our licenses are always royalty-free. Interestingly enough, our kernels, MicroCOS 2 and MicroCOS 3, we actually provide the source code there free of charge for evaluation, which is kind of a unique thing, and we'll go back to that in a moment when I speak more on Harmony. As far as PIC32 support and microchip support in general, Micrium has a pretty lengthy history there. We actually have been running on the PIC32 since pretty much its release. We actually worked with Microchip while they were developing the part. We got the alpha silicon, beta silicon. We developed our port on that. The port has been modified a few times over the years based on input from Microchip. So at this point, very stable kernel port, and it's the PIC32 is a platform we supported really since its inception. Prior to that, we were actually running on PIC24F from Microchip, BS PIC33s. We even have customers who've run on PIC18s. So we certainly have some Microchip expertise in-house. As far as applications that Micrium supports, we're really all over the board. You know, we have customers in pretty much every industry. We have customers in communications and consumer electronics, automotive, but we really do have a large number of customers in safety critical areas, especially medical, aerospace, industrial controls. And a part of that is you know, a consequence of how our software has been written. Our software has always followed rigorous coding standards. That's been something that Jean has advocated since he started the company. We've always had coding standards in place. Those coding standards are available on our website. Jean's always been a big supporter of coding standards in the industry in general. And a major result of that is that we've been able to achieve a number of safety critical certifications with the kernel. And I know, you know, right now in the industry, safety critical is certainly a big buzzword. You know, if you go to any trade show, or if you look through any software, hardware providers, marketing collateral, chances are you're going to see a couple of terms, IoT and safety critical. And I'll spare you my rant on IoT for this particular presentation. We can move past that one. But safety critical is something that's definitely worth focusing on here, because, you know, for Micrium, this is more than a buzzword or a marketing fad. This is the way we've developed software from the beginning. And as I mentioned, we have many certifications for the software that are proof of that. With our kernel, we're certified to DO-178B, which is the aerospace standard. Actually, we're certified up to level A there. So we've been used in basically the systems that achieve the highest level of safety criticality in aerospace products. We also have IEC 61508 certification. We've been used in many medical products, which would be IEC 62304. So we really feel like the approach we take to writing software, the attention to detail and the adherence to coding standards, has some very tangible benefits for our users. As I said, safety critical, really not a fad for us, really not a trend. It's always the way we've operated. If you look at the history of MicroCOS 2, it was actually first used in a DO-178B certified aerospace product in 2000. So really we have 15 years of experience there in certified aerospace products, which are obviously very demanding applications. So normally when, you know, customers ask me, or potential customers ask me, what separates Micrium from other RTOS providers, I'm usually not going to go immediately to features. And this is not to say, you know, we don't have good features, or that, you know, features of an RTOS aren't important in selecting your software. But it's to say that, when I go to most of our satisfied Micro-C OS2 and OS3 users, the things that they're going to point out to me that are important in their projects are the code quality first and foremost, which really results in the reliability of the software that you can see in the certifications I just mentioned. The documentation, Micrium has always been very adamant about thoroughly documenting all of our software. So all of our modules have user's guides. We've written numerous books around our kernels, around TCP stack, around our USB stack. So documentation everywhere, even within the code. Everything's heavily commented inside the code. You get half-page comment blocks prior to every function describing the arguments for that function, the output. So it should never be the case with Micrium software that you don't know how something works. You should always be able to find reference materials indicating how the software works and how you can use it. And then another point I would make about Micrium software, another strong point, is our support. This is certainly a benefit that we offer when compared to open source solutions. With our licenses, you get a year of support. It means you can email us, call us, and we have a dedicated support team here that's very quick to get back to you and answer your questions on how the software works. So if we turn to Harmony, I think there's a lot of marketing terminology used in conjunction with Harmony, but I think that the basic idea, at least the way Micrium sees it, is that Harmony helps us to answer a very common question that we get in technical support as an RTOS provider, and that is, does your software run on my board? And the reason I say that is that all of the software providers you've heard from today have somewhat limited resources. It's just impossible for us to write every piece of low-level code that we would need to support every embedded platform that's out there. So we have to kind of pick and choose. We pick the platforms that we think are going to be popular, and we pick sets of peripherals that we think will be popular on those platforms. So when we get a question, does it run on my board? Oftentimes it's going to be a partial yes. We're going to say, well, we can run this component or this component, but it's not going to be everything. And to fill in the gaps, we're probably going to ask you to go to someone like Microchip and get low-level code from them, get their drivers. Well, in the past, that was a little tricky, because you go to Microchip, you get an A to D driver, you get an SPI driver, you get an IO driver, and those probably were not originally written to be used with a kernel like Micro-C OS2 or Micro-C OS3. They were written for a single task environment. So the idea is if you have multiple tasks under your OS2 or OS3 based project, and they're both using the A to D converter, or you have multiple tasks that are all using the IO port, you're going to have to protect that peripheral as a shared resource. You're going to have to use kernel services to make sure that you don't have conflicts over access to that peripheral. You're also probably going to have to rewrite some of the drivers that are polling and setting in loops waiting on bits to be set. These are things that are going to result in task starvation and just poor performance in a multitasking environment. So again, in the past, when we said, well, you need to rely on some of Microchip's drivers in addition to our code, it wasn't always the greatest arrangement. And what we have with Harmony now is a collection of drivers, a software framework that use what they call an OSAL, an OS abstraction layer, to ensure that shared resources are protected. And that you're not doing things like setting in loops, which are going to cause performance problems in your kernel-based application. So now you have this framework of low-level code that can be used with something like Micro-C OS or Micro-C OS2 or Micro-C OS3 to definitely make your work as an application developer a lot easier. And as it was pointed out at the beginning of the presentation, there's what's called the MPLAB Harmony Configurator, MHC, as part of this package that makes things even easier, because it now takes this framework that you have, all these drivers and pieces of low-level code that are kernel aware, and it allows you to automatically add those to a project. And this is something very powerful. I was actually working on some material today for the master's class that Micrium normally gives. And it used to be the case if you wanted to create a kernel-based project from scratch and bring in a lot of Microchip drivers, you would be manually adding a large number of source files, several kernel files, driver files, to your project. And with configurator, it's literally a matter of a few mouse clicks that you click. I want to use the kernel, I want to use these drivers, and the entire project is generated for you with all the necessary source and header files. So very powerful tool and something that helps you get started very easily with Micrium. And the nice thing with MicroCOS 2 and MicroCOS 3 and Harmony is that we actually have provided all the source code for you within this tool. So I mentioned earlier that we have this unique model where even though we're a commercial RTOS vendor, we make our kernel source code available free of charge for evaluation. And so we've done that with Harmony, where you can go in the configurator tool, you can select MicroCOS 3 as your kernel, and it's going to put together your project with all the kernel source files there. So you have all the source code, all the commenting I was mentioning earlier, full kernel capabilities right out of the box with Harmony and MPLAB. So very nice way to get started with Micrium. So you can go to the Microchip website to get that, to get Harmony, and get started with MicroCOS or MicroCOS 2 or MicroCOS 3. And as I mentioned earlier, Micrium will have a class of this year's Masters who will be going over that project. So the Masters convention in Arizona will have an OS3 class. We'll put together projects, and we'll get an overview of Harmony and how you can use it to build multitask applications.